So the essential question for today is similar to the last lesson, which is how can transformations of functions be utilized to graph piecewise and periodic functions. So we're going to look at shifts of piecewise functions today. At the end of the lesson, we get into what we call periodic functions. We'll talk more about what that means. You all have the resource page, so if you need help with number 15, how is Q of x a transformation of P of x? Well, Mariah already answered for us that is left 2. Use the graph that you have to sketch that. So you would take this parabola and you would move it to the left 2. So you take all of your points and move them left 2. I would use points that are, you can see on your grid to do that. And again, it's just a sketch. Remember, a sketch is better than a kindergartner, but it doesn't necessarily need to be a work of art. Okay. Then what would the expression be in terms of x? So basically, we take our original equation, and we're going to use function composition and substitute our shifts into here. Now, we only have one shift to worry about, and that's a horizontal shift. Horizontal shifts are always in parentheses and opposite. They give you what that shift is, x plus 2. And you would want to substitute that everywhere there's an x. So the new equation for Q of x would look like this. Now that brings us to the question of, should we simplify that or should we just let it how it is? Because you could simplify that. You could square your quantity x plus 2, combine like terms, and simplify. And that's fine. Okay? But this version of it helps us recognize the transformation easier, faster than simplifying it. Okay? Number 16, the graph of f of x is the cubic graph that you see there. We could discuss how we know it's cubic. If you had gotten to chapter 7 of Algebra 2 and learned a little bit about polynomials, you would know that because this has 3 x-intercepts, you know that it has to be cubic. Okay? But it doesn't actually give us the equation of it. That's okay. Still asking us to shift it though, right 1 and up 3. So again, take your important points. Important points would be x-intercepts. Other important points would be vertices. And you would move those points right 1 and up 3. Again, this should be review. These are things that you should have done in Algebra 2. I'm shifting all my x-intercepts, y-intercepts, and vertices. To get, again, a sketch of that graph. Right 1, up 3. Should be review. Okay? Now, the reason we're reviewing that is because today we're going to be talking about piecewise functions, which is a topic of yesterday. Graphing just pieces of functions. The first one we're starting with is x squared is defined as x squared when x is less than 2, x plus 2 when x is greater than or equal to 2. The first step will be getting that graph. Okay? The first step will be getting that graph. So, on our grids, okay? Which hopefully yours is better than mine. So we're looking at a parabola piece of this piecewise, x squared when x is less than 2. And we're looking at a linear piece, x plus 2 when x is greater than or equal to 2. So just like yesterday, you could use your calculator and the table function if you'd like. Most of you should be able to graph x squared though. Beginning at 2. So what is 2 squared? 2 squared is 4. I used an open circle because it's not equal to, it's just less than 2. And now I'm going to the left. Less than is left. So 1 squared is 1, 0, and then it is symmetrical. So the parabola piece of my function would look like that. Now, I get to the linear piece, x plus 2, starting at 2, and it's equal to 2. So 2 plus 2 is 4. Well, that ends up being the same exact point of my parabola. So the open circle that I just had now gets filled in by my second piece of the function. So I would now fill that circle in and graph the rest of that line, which has a slope of 1. So I have a parabola piece and then a linear piece. Now, yesterday I asked you a question about continuity. I said, is this function continuous? Try to visualize what that piecewise function looked like from yesterday. It was a parabola and a line, but they weren't connected. Some of you said yes, it was continuous. Some of you said no, it wasn't. I didn't share with you what the right answer was. Today I'm going to ask you the same question, because this graph looks different. Yes, it's piecewise. Yes, it has a parabola and a linear part to it. However, it is different than yesterday. It's clearly different. Is it continuous? Yes or no? How many think yes? Okay, so people that said no yesterday, that it was not continuous, you were right. Why were you right? Benson.
Because the book defined it as a function that you don't have to take your pencil off the paper to graph.
Correct. The dummy definition is a continuous function will be a function you can draw without lifting your pencil. If there's any gaps in there, whether they're horizontal or vertical, you can't draw it without lifting your pencil, which means it would be not continuous. In this case, this function is continuous because you can draw the whole thing without lifting your pencil. In Algebra 2, you learned about one function that was not continuous. What parent family in Algebra 2 was not a continuous function? Toby?
Hyperbola.
Hyperbola, very good. Now, this problem here is asking us to sketch that graph. We did check. Let h of x be f of x quantity minus 1, x minus 1. So that would be a horizontal shift of what? Horizontal shift to the right 1. So basically you're taking all of the points in your original graph and you're moving them right 1. I think everybody here can do that. So you still have the parabola piece, you still have the linear piece. Now I want to write an equation for it. So we're going to manipulate the original equations here to include horizontal shifts to the right 1, which means I'm going to need parentheses because it's horizontal. So quantity squared, inside of that, I'm writing an x minus 1 because horizontal is always inside and opposite. What about the linear piece? What will that look like without simplifying it? What would it look like? Kirsten? Correct. Quantity x minus 1 and then plus 2. Now again, you could simplify that if you wanted to just x plus 1, but it's easier to see the shift if you don't simplify it for now. There's one more part of h of x that's going to be different. When you look at the original compared to the new graph, you have a parabola piece and then a point, a place where it turns into a linear piece. That point changes. Benson, what's it change to? 3, which is 1 to the right of 2. So it matches our horizontal shift. So our new domain, x would have to be less than 3, and x have to be greater than or equal to 3 for that piece. Would a vertical shift impact that part of our function? No, only a horizontal shift, because only horizontal shifts affect domain. For the function, the transition point occurs at 2. Where does the transition point for h of x? We said 3, so that changes that. Find the piecewise function for h of x. We already did. We wrote it in the space provided on your resource page. Okay. Number 18. I want you to go ahead and try that one right now on your own. So we're going to talk about k of x now, which is still f, but now it's getting moved this shift, which would be right 2, and this shift, which would be down 3. I want you to sketch it. I want you to see if you can write the function for it right now. Go. All right, so you see the original here pictured in black, and then we move that left 2 and down 3. The sketch part should be easy. Everybody here needs to be able to do that if you passed Algebra 2. Writing the function, though, again, horizontal is inside of parentheses. So x plus 2 is the horizontal shift. Minus 3 was the vertical shift. Okay? The linear piece looks a little goofy. We have the plus 2 for the horizontal in parentheses. We have the minus 3 for the vertical outside of the parentheses. And then we have the plus 2 of the original problem. Again, you can simplify that if you'd like to. So all of that, because those parentheses here have no power whatsoever. Okay, so plus 2 minus 3 plus 2 ends up being x plus 1. And that's okay. On a quiz, I would accept that answer just as much as I would accept this answer. I know the answer I have written here originally looks goofy because you got a lot of stuff in there that could be simplified. However, the intention there is so you can see the horizontal shift, the vertical shift. Again, this part is important. It is not the same as the original. Only one of the two shifts we had affects it. Which one of the two shifts, again to review, affects it? The horizontal shift, okay? That's the only one. So the left 2. So if we were at 2 on a number line and we go left 2, we end up at 0. Or you could use the graph to observe. You got a parabola to here, and then you got a line. So right there, that will be the x value of 0. Okay? What are the domain and range of that graph? Domain, walking around, I think everybody got that. The domain was all real numbers because it keeps going in both directions. The range is the one that's a little different because it actually has a minimum of 2 and a maximum of 4. So you'd be looking at all your numbers in between 2 and 4. Y-intercept is a minimum. You already know the minimum, okay? So the y-intercept would be 0, 2. Are there any asymptotes or symmetry? There are no asymptotes. An asymptote, by definition, okay, is a point or place on the graph that a line approaches and keeps getting closer to but never actually touches. That's our definition now. That'll change in chapter 5 a little bit. Here, there are no places the graph approaches. All right? I mean, yes, it has a lot of vertices because it keeps going up and down and up and down, okay, but no asymptotes. Does it have symmetry? We're going to say yes. It has transitional or slide symmetry. And does the function belong to a parent family? No. So, number 20, a little more with that function. Looking at that graph and knowing that the period is 5. Okay, you can answer the following questions. Does f of 2 equal f of 17? Well, the shortcut way, or the way to illustrate that, is by taking 17 minus 2 and getting 15. And then, is 15 divisible by the period? Whole, yes. 15 divided by 5 is 3. Okay, so those two points would be the same y value on the graph. And if you looked at the graph, you could figure that out. 2 is right about here. Okay, 17 is right about here. Okay, or you could draw a horizontal line to see if they are equal. And as long as they both touch that horizontal line, then they are. Okay, and then is f of x equal to x plus 5? Well, this is a left shift of 5. Any shift of 5 is going to be equal. That's the slide symmetry I'm talking about. Give me another horizontal shift that would make this equal again. Benson? Yeah, sure. So f of x minus 10 would be the same as f of x. We're just shifting it to the right 10 units, which means it's going to match right back up over top of itself. That makes sense. All right, so on the resource page, it reaches maximum and minimums by inspecting the graph, estimates solutions, where f of x is 3. It says estimate. So that means, whoa, didn't want to do that. Okay, so that means we're drawing a horizontal line, okay, where x is 3, which would be halfway between 2 and 4. That doesn't show up. So a horizontal line between 2 and 4. All the solutions would be all these values. Okay, and they'd all be estimates. Okay. Last, number 21. What is the period of g of x? Choose 2 points that you know. Easy points, like maximums or minimums. How far apart are they? They're 7 units apart. So the period here is 7. Name 6 values of x where y is 1. So you go to y equals 1, that horizontal line, 6 values of x. Okay? So we can name them right here. Negative 2.5, 1/2, 4.5, 7.5, so forth. Okay? Every 7 apart. All right? What is g of 53? How do you know? Well, we can't extrapolate this graph 53 units to the right. Draw that out. So there's a shortcut. You take the number you're trying to find, 53, and you divide it by your period. How many times does 7 go into 53? 7 times. But that's not the important part. The important part is the remainder. What's the remainder? 4. That means it's equivalent to 4 on your original graph. So if I go over to 4 and I go up, I will see my y value is 2. So g of 53 is equal to 2, which is also equal to g of 4. You divide by the period, whatever the remainder is, tells you where to look on that original section of graph. This whole class is about periodic functions, so we will continue to see this over and over again.